Hello friends, this is the ninth video regarding electrostatics. Till now, if you have not liked all the videos and subscribed, now you like it and subscribe it. Now in this section, we should deal with vertical circular motion in the presence of electric field. Okay, body is moving in this vertical circle. Now just see, this is the center of the circle. This much is either length or r. An object of mass m having some charge is tied to a string of length L. So this is your hand, you rotate, or this is the fixed point, length is fixed at the center. You take that length as a radius of the circle, and your aim is to rotate that mass in a vertical circle having the radius L. Okay? Now here, just to consider, the system is in vertical electric field. Okay? System is in vertical electric field. Now assume the direction of electric field is vertically down. Okay? If the direction of field is down, at the lowest point L, weight of the body mg is vertically down, and force due to electricity or force due to the electric field is again vertically down. Okay? So net resultant force is now mg plus EQ. Now if you consider the object is displaced some distance x, then same force is acting here. If acceleration in this case is a, then ma that equal to EQ plus mg. So from this, a is EQ plus mg divided by m. This is the acceleration acting, but object is displaced some distance, angle theta. This angle is geometrically theta. So the acceleration of motion is, therefore acceleration is a sin theta. Okay? Now if you displace this object and release it, then the object oscillates in between these two extreme ends. That means x represents your displacement maximum, that is the amplitude. So now here the driving force is mass into acceleration. Acceleration is a sin theta, or you can take the effective acceleration is g prime sin theta, because generally in the absence of electric field we are taking g sin theta. So replace as g prime sin theta, you take, this is a concept. Okay? So now a sin theta means this is g prime sin theta. Practically theta is a very small. So this is a into sin theta means x divided by L, arc divided by radius. Okay? Arc divided by radius, that equal to EQ plus by m plus g whole into x divided by L. Okay? Now from this you find out what is x by a. What is x by a? This is x. Okay? So this is your resultant acceleration. You take a sin theta is a g prime sin theta. You take, this is a. Let us correct it. This is a. Now you take, this is mg prime. So g prime is this is. So driving acceleration, you take, this is a driving acceleration. Let us correct it. G prime sin theta. So now from this you find out x by a. Okay, x by a is L divided by EQ by m plus g. So what is your time period? that is 2 pi root over displacement divided by acceleration. This is your time period. So now this is 2 pi root over x divided by a. So this is 2 pi root over x by a. You can substitute L or R divided by, you take g first, plus eq divided by n. All are in root. Okay. So accordingly you can calculate that is what is frequency. Now this is the case if an object is displaced in the presence of downward electric field in vertical circular motion a very negligible distance, that means angular amplitude is very small, theta is very small. In that case you put sin theta approximately equal to theta. You can put this is g prime theta. Theta is arc divided by radius. Arc is x divided by radius is L. Okay. So you can calculate. If you assume the same thing, but the direction of field is vertically up, if this is the case, instead of this. Now this is the direction of EQ. This is mass M, charge Q. Direction of electric field is vertically up, means charge Q experiences force along up, but direction of mg is down. You take same point, same situation. This is the x distance. Okay, so this is the direction of the acceleration. Now if you take the direction, if you reverse the direction of the electric field, same figure, what should be done? Now from this you write what is A. A is your G minus EQ divided by M into x by L. This is the formula. G minus EQ by M into x by L. You substitute this. Okay. So from this you find out what is x by A. Then find out what is T. T is 2 pi root over displacement divided by acceleration. If you substitute in the same, then you will get T equal to, that is 2 pi. X is L. X by M is L divided by, this formula is replaced, that is, this is G minus EQ divided by M. This is G plus, this is G minus. Okay. Now if you immediately switch off the electric field, what happens? Electric field is 0. This is 2 pi root over L by G. Electric field is 0. This is T equal to 2 pi root over L by G. That means if there is no electric field, the time periodic formula is 2 pi root over L by G. If there is electric field in vertically up, this is the time. If vertically down, this is the time. Okay, sorry. This is the vertical down and this is the vertically up. Accordingly, you can calculate the frequency. Okay. Now, let us consider only vertical electric field. Okay. Vertical electric field, or you take vertical downward electric field. You consider this figure, first figure. Now in the vertical electric field, just to imagine the object start here with velocity VL and the minimum velocity at the highest point is let VH. Object is moving along the vertical circle like this. Okay. Now come to this point. This point is this. Okay. This is the point L. Number of processes mg and aq. But tension TL is acting towards the center of the circle. Now the body is curved upward. That means this shows that TL is greater than aq plus mg. That means TL minus aq plus mg, that equal to your centripetal force mv square divided by L. This is suppose one equation. Okay, upward force minus backward net force, that is equal to resultant force. What is VL? VL is the speed of the particle at the lowest point. Similarly, you come to the highest point, that is H, this point. Tension is TH towards the center of the circle. Weight of the body is this direction. Electric field EQ is again along downward. Okay, so all are along downward. Therefore, you take TH plus EQ plus mg. I am putting a bracket sign like this. This is TL minus TH plus some identical terms that equal to mVH square divided by L. You put this is equation 2. This direction is TL, highest point. This direction is EQ. This direction is mg. So all are combinedly providing the resultant centripetal force, that is mv square by L, where VH represents the velocity at that point. Okay, that means if EQ and mg is large, then the contribution of TL is negligible. This is the question. They are all are in downward reach. If EQ and mg are large, then the contribution of TL, sorry, it is not a TL, it is a TH. Contribution of TH is very small, because we know that for minimum, for just completing vertical circle, at the highest point TH tends to 0. Okay, this is our combination. Therefore, you can got two or find out two equations: tensions in the lowest point and at the highest point. Okay, now for just to complete, if you take the vertical motion, then what is TH? That is equal to 0. That means highest point, at the highest point tension must be equal to 0. So from equation 2 you can find out VH square. Okay, VH square, that is equal to L, that is L by M into EQ plus mg. So you will get equation 3. If all other properties are given, it is possible to calculate what is the minimum velocity required at the highest point in the presence of the electric field. Okay, highest point in the presence of the electric field. Similarly, from this equation you can calculate, that is m. You take this m here, VH square, this is L into EQ plus mg. Okay, now you just put a half sign, multiply. So this will give you, that is the kinetic energy at the highest point. Okay, this will give you the kinetic energy at the highest point, that must be equal to half L into EQ plus mg. That means if E is given, Q is given, mass is given, L or length is given, then you can find out the value of kinetic energy with this formula. This is the kinetic energy, minimum kinetic energy at the lowest point. Okay, now if you take the value of VH, if you put the value of VH, okay, then you can find out the value of VL in another equation by using. Now, to find out VL, you can use the energy conservation, to L and H, to lowest point and highest point. Okay. Now, at the lowest point, kinetic energy is half m VL square. At the highest point, potential energy is half m VH square. Therefore, when the object displaces from this point to that point, its kinetic energy lost half m VL square minus Vh square. This is the energy lost by the particle when it is moving. But at that time, what is the energy gained? Energy gained is, that is, net force is mg plus ql on that body, because mg and eq, this is mg and eq, they are along same direction, into net distance traveled by the body, what you call mgh. This is, you take, this is mg prime and h. G prime is mg plus eq whole by, okay, mg prime is mg plus eq and h is 12, you take. So this is your loss of gain in kinetic, potential energy, and this is a loss of kinetic energy. Okay. Now, if you put equation 3 Vh square in this equation, this is equation number 4, that is Ug, that is 3, that is in 4, that you can get what is the value of, that is Vl. What is the value of Vl? First to find out Vl square, then find out Vl. So in this way, it is possible to calculate the velocity at the lowest point, velocity at the highest point. Once you got the velocity at the lowest and highest points, then you come to equation 2 and 3. Okay, these are the not equations 2 and 3. This is equations 1 and 2. Now you come to the equation 1 and 2. If you put the values, then you can get highest tension at the lowest point. What is TL? Highest tension at the highest minimum tension at the highest point, that is TH. And similarly, if the particle is somewhere here, okay, somewhere here, with the help of vertical circular motion principle, you can calculate. Now, again, the same thing will repeat. The same thing will repeat in this case. Okay, if the electric field is vertically upward, this is vertically downward, this is vertically upward. What can you do? Only just substitute, okay, minus EQ, that is instead of EQ, you will get answer. Just you substitute minus EQ instead of EQ. Okay, whenever there is EQ, you put minus EQ, so you will get all answers if this is the case. Okay, now this is the again a mechanical application of electrostatics. Application is to vertical circular motion. Now you can imagine another form. If electric field is in any arbitrary direction, suppose object is moving along this direction, okay, vertical circle. Suppose electric field is neither up nor down, it is moving along this direction. It makes an angle theta. Therefore, its one component, that is E sin theta, helps for vertical motion. Another component, E cos theta, it pulls the charge towards this. If the object is not fixed, then the object will pull towards this. Therefore, in that case, the body will describe this type of a path, that is called a helix. It is also possible in this case. Okay, thank you. If you like this video, like it, share it and subscribe it. Thank you.